Hey everyone, Mr. Kimson here, and today we are looking at range and interquartile range. Now, back when I started high school, we kind of had to join the school choir because we were doing the music course. And back then, I had a pretty squeaky voice, so my range, I guess, was pretty high. Um, Nowadays, I probably couldn't even tell you what notes these are, to be honest. I'm gonna have a guess. I can already see all the music students kind of cringing here. That okay? We're working with treble clef. That's a D. So that's a C. Is that a B? A B flat? Do they even write B flats like that? I don't even know. I'm sure someone will correct me. This one though, I have no idea. If anyone can tell me what note this one is, that'd be great because I genuinely don't know. But we're gonna look at range in a mathematical context here, right? How is that gonna look? Well, range in a mathematical sense, what we have to do is we actually have to consider what we call a measure of spread. And a measure of spread is basically a numerical value and determines how similar or varied, I suppose, a data set actually is. Okay, if you think about like exams, for example, right? Maybe someone does really well in an exam and they get 99%. But if someone doesn't do so well, they maybe get 19%, right? And they think, okay, I can improve for next time. That's okay. But you look at this, and there is quite a large range, right? The range is pretty big. It's like, what, 80, right? And so we're thinking about how can I give a number which represents how spread out something is. Now, the issue with the range, this is the range, right? Literally the highest minus the smallest value, or the max minus the min. The issue with this one is that it's not a great representation. Have a think about why. It's not a great representation because the issue is that may be one individual student, right? What if I want a number which represents the range of all of the scores, right? Like what happens if someone got 19 and someone got 99, but everyone else got, 80% and above, right? Would you say that that's a fair representation of how spread apart things are if we just take the largest and take away the smallest? Not really, right? So the way that we consider that is that we actually look at, okay, let's try and factor in some of the other values that we have. And this is where the interquartile range comes in, right? The interquartile range looks at also not just the highest minus the smallest value, but it does this calculation, it does Q3 minus Q1. And you may recognize this as the third quartile and the first quartile value, or they also refer them as the upper and the lower, right? And basically, what we do is we split our data set into 4 equal groups using 3 numbers, right? We use the median, which is often written as Q2, and we use Q1 and Q3. And then so what we end up with is we end up with these 4 sections. And by doing Q3 minus Q1, this one here and this one here, if we subtract those 2 values, that's going to be another way that we can calculate the interquartile range, a measure of spread. It's going to be giving us some, I guess, more accurate value of how things are spread out, right? And we can actually kind of keep doing this. And there are other more measures of spread that consider actually every single value, and we'll have a look at those next lesson, in the upcoming lessons. Now, I've posted some stuff on how to actually calculate these from a numerical set, but I want to focus on doing this graphically, right? Because this is an important skill as well, not only constructing them, but doing this graphically. So range and interquartile range here. So the largest and the smallest there, I can see that. So what's the range and interquartile range? Well, the range would just be 12 minus 7. And that's going to be 5. If I wanted the interquartile range, now remember with a box and whisker plot, what do all these values mean? Well, this one here is the median, that line in the middle of the box. This is my max value, this is my min value. And so Q3 and Q1, these are the edges of the box here. So Q1, Q3. And so the interquartile range, or often abbreviated as IQR, is going to be Q3 minus Q1. And that's just 11 minus 7. And that's just 4. Okay, so that's from a box and whisker plot. Now, another thing they might want to know is, this is an interesting type of question, so it's looking at marks between 2 different tests. And I suppose one thing to think about is, hey, how do you know who which one does a class do better in, right? For example, in this one, in the maths test, we've got a really high mark over here, but we've also got a really low mark over there, lower than the science test mark, right? So it's interesting to compare. How do you determine which performance is better? And so these measures of spread are one way we can look at that, right? So what they're asking, what they're interested in though, is actually which measure must be the same for both tests. And the key thing here is must be. There must be a conclusive way to determine that. Let's look at the first option. So the first option is the mean. Now with the mean, in fact, from the box and whisker plot, we don't really have enough information, right? Because the box and whisker plot tells us, okay, I know that there's a particular value as the median, Q2. I know that these are Q1, Q3. I know I've got my min and max. But it doesn't actually tell me like what values are in between. It tells me the distribution. Like I know that 25% in each of these sections. That's what the whole point of using quartiles is. It splits it up into 4 equal groups. Although I know that distribution, I don't know what actual values are there, right? Even more so, like over here on the scale, there are no values that are given to me here, right? So there's no way that I can know if the mean is conclusively the same, so that's not an option. The range, similar thing here, the range, you can clearly see that the range over here, right, that one is much larger than the science range, which is smaller there, okay, so that's no good. The median, well, where's the median going to be? The median is this one over here. So this line in the middle, and you can see that they're different values. Yeah, they're not on the same tick mark. They're not the same place. Now, the interquartile range, how is that determined again? Well, from your formula above, that was Q3 minus Q1. Now, although I don't know any values that are here, I've got this scale here, and assuming that this scale is even, right, then I can see that the interquartile range for the maths test covers 1, 2, 3 of these tick marks. Yeah. Now, look at the interquartile range for science, right? Although it doesn't start at the same place, look at the size. It looks very similar, right? So if I count across, let's use a different pen here. Let's see, it goes across, starts from here, 1, 2, 3. Okay, you can see that it covers 3 of those tick marks as well, and it ends here and here, right? So that means that interquartile range is my answer for this question, right? They have the same value because when I do Q3 minus Q1, they give me the same distance. Okay, so that's box and whisker plots.